Okay, so to get a handle on arc length, we have to understand how the approximate contribution to arc length, which is the length of this segment, due to the delta theta. Well, we want to get an expression for it. Now, we could use the law of cosines and get an expression, but that's not particularly informative. So we don't really want to do that. So we note that this is going to be longer than this, okay? And let me find a piece of chalk of an appropriate color, okay? Roll call. Then this, got my white chalk and it's disappeared from the face of the earth. And this here is longer than this. Okay? Why is that? Well, think it through. Why is this longer than this? And what could we use as an expression, an approximate expression that'll become exact as theta approaches zero, will approach being exact as theta equals zero. Okay, so my question is, why is it so? And how can we get an expression for the approximate arc length, implicitly the approximate arc length due to this delta theta increment between theta and theta plus delta theta? Again, you want to ponder this. Don't just go on and look at the answer. Think about it, because you want to be able to think kind of visually and geometrically and ponder through it so that you can really understand it in some depth. Okay. Well, I assume you've paused and pondered. Is there a way you can combine this picture and this picture if you haven't already done so? Combine this picture with this picture to get a handle on an expression for the length here. Again, you should ponder that if you haven't come up with anything. How can this and this be combined? Okay, well, I'm going to show you. Let's again take this picture. And combine it with this picture. Well, this combines with this. This is almost the same as this, except that you have this thing here with an approximate right angle here. An approximate right angle here. Now, that's another hint. Can you think about how we can then express this length in terms of just r of theta, delta theta, and r of theta, r of the quantity theta plus delta theta. You should ponder that. How can we get an expression for this? Now, hopefully you're seeing it, but I'm going to go on now. If you haven't pondered, go away again and ponder some more. Well, the key is, this is approximately a right angle, this is approximately a right angle, and so is this. Again, ponder if you haven't got it. But I'm going to continue. Meaning, of course, that what we have here is a right triangle. Approximately a right triangle. So, this, well, I was hoping I wouldn't have to lean over and pick up this chalk, but I do. Okay. I'm fine with that. If I haven't been standing around for a while. If I have, these are a little stiff. Okay, so anyhow. Well, here's an enlarged view of the triangle. And this angle here is nearly a right angle. And as we approach delta theta equals 0, this approaches a right triangle as a limit. Very important concept. Okay? So if we know two legs of this triangle, if we know these two legs, we can find the hypotenuse using the Pythagorean theorem, simplest thing in the world. So, extending the hint, what's this leg? And what's the length of this leg? Ponder it, it's all right there in front of you. Almost all. Okay, well, again, hopefully having been pondered, it's obvious then that this leg, well, if you look at this triangle here, this distance is r of theta. Well, here it is again. This distance is r of theta, and this distance is r of theta plus delta theta, so that this leg is r of theta plus delta theta minus r of theta. It's a difference between this and this. So I'd better draw this bigger again so I have room to label the thing, like the foresight there. Okay, now we've already talked about what this one would be. What's this one? Think back, what have we done so far? How have we determined the length of this leg? Well, that's just this. It's r of theta delta theta, approximately. Now, a little more rigorously, we would want to use a sample point between here and here, a sample angle theta star. It'd be an r of theta star, delta theta star. But in the limit, that's not going to make any difference. It's still going to approach, r of theta delta theta is still going to approach the same thing as an r of theta star or delta theta star for some angle between here and here. Okay? Something you should understand, you should have pondered things of this nature in your calculus course, in your first year calculus. So that now we can say what the length of this leg is. So you want to write that down. Okay? What's the length of, I said leg, what's the length of this hypotenuse? Write it down. Okay, hopefully you've written it down. If you haven't, pause and write the thing down before I do. See if you're right. And, see if I'm right. If I'm wrong, let me know. Okay, so we have R of theta plus delta theta I almost said something wrong. I did, I wrote it down. It's this. Square root of all this. Just let that square root sign go down far enough that it covers everything, okay? Okay, well, can you expand the square and simplify this as much as possible? Again, you should pause and do it. That's what we did in class. Okay? Well, you're squaring this difference, so you're squaring a binomial. And you're going to get r squared of theta plus delta theta minus 2 times this, 2r of theta delta theta, r of theta, minus 2 times that, okay? And then r of theta squared we're running out of room to write it, because it's kind of a long expression. So if I'm going to be prudent about it, I better give myself as much room as possible. Okay, so this it's r squared minus 2, get a little hard to write, r of theta times r of theta plus delta theta. Plus r squared of theta plus r squared of theta delta theta squared. Pondering whether I'm going to be able to do everything concurrently on this board, didn't leave myself much room. Okay, well, we're going to have to deal with it with the space, with the space question here, so we can do this coherently. Ponder this. How can we simplify what's under the radical there?